Hi, I'm WendyArlint, and I am going to run through Zemlin's parameters of normal vocal quality and what that would look like if I were to do a vocal analysis report for someone. And I'm going to use, of course, my own voice today as a sample and an example of how I would do this using Pratt. So my first thing I'm going to do is open up the program Pratt. I don't need this. I'm going to close that out. I'm going to record my sample. The world is very large. I'm going to save this over here. And I'm going to view this. Okay, so here I have a whole bunch of information here to help me be able to assess a voice. The first one is maximum frequency range. I can pull up this information in a couple of different ways. The first way I can do this is highlight, and I could get my maximum pitch. My maximum pitch is 312. I could also pull this up by showing my pulses up here and pull up a voice report. And this gives me a lot of good information. It's not completely accurate. I mean, it's as accurate as it can be, and I know I can do this even better with more time. But from what I'm learning is it's going to give me a pretty good estimation and an idea of how to do a voice analysis. Now, for pitch, I have the mean pitch, which is my F0, as 224 hertz, and that's normal for a woman. I should have about a standard of 200 for my pitch, or higher, because I am a woman. My maximum pitch is 312, so that shows me that I've got some good range in there, about 2.5 octaves. Now the next component was my speaking F0, and I accidentally said that first. It was 224 hertz. Okay, my maximum phonation time should be about 15 to 25 seconds. Now I just have a time range selection of 0.34 seconds to 3.0 seconds, though my duration is only 2.7 seconds. Now this is not my test for duration. I'm going to pull up a timer here. A healthy voice should be able to sustain a vowel for a phonation for about 15 to 25 seconds. And of course, if I were a child, it would be less. It would be about 10 seconds or less. Now I'm going to just say ah for 15 seconds. Alright. Okay. So that's just my sample of healthy voice sustaining ah. And I did that, and I should hold that at different time, or for at least 15 seconds. Okay, if I can't do that, and if I have an inability to do this, it would definitely show that I have a problem in my valving airstream for speech. Okay, so the next parameter is going to be my minimum maximum intensity at various F0 levels. Now I should be able to have an amplitude higher at different various levels for between 20 and 30 decibels. Okay, so I'm going to show that again with my report. Oh, actually, this isn't in there. Okay, excuse me. I'm going to show that with intensity. So that's why I had intensity showing up. Okay, so my maximum intensity, oops, I need to highlight it first. Still learning. Okay, my maximum intensity is 87 decibels. Okay, and then my minimum intensity is 30 decibels. That's a difference of 80 from 50, which would be 30 decibels. So that's good. I have a perfect in the mid-range frequency. Okay, so I'm in my mid-range. I'm not up in a higher, I'm in my modal frequency right now. Okay, now periodicity, which is next, of vibration, this is reflected with jitter, and this can be easily shown when you go to pulses again, show pulses, and then I'm going to get my voice report again. Okay, so jitter is 1.4%. So I have a little bit of jitter in there, and everyone should have some jitter in their voice. And jitter is going to measure the periodic deviation in my voice signal, or my pitch perturbation, which is when I have a cycle of speech with my F0, it should show me what my sustain is. How much period do I have in that speech? Okay. Everyone's voice will have jitter, and a healthier voice should have a higher jitter. So I should see, if I was looking at a weak jitter, I would see a lower percentage here. And this is another way to show if someone is having a difficult time with their voice, because we'll be able to see if they can sustain their speech or not. Now my last parameter I'm going to measure is the noise generated by turbulent airflow. And this is shown in my mean noise to harmonics ratio. If I had a really creaky voice, I would need to change the parameters on Pratt to be able to pick up those lower tones, but I don't. I'm a woman. I have kind of a breathy voice, so I am going to see that there is going to be some noise in my voice, and it's just going to be a little more like airy. and it's just because I'm a woman. But if I had a hoarse voice, I'd have to try and pick up those parameters too. Everyone has different kinds of noises now, depending on if they had a voice speech problem, like say roughness or hoarseness, then I'm going to see some noise being picked up in this area, in my harmonicity. And that really helps us measure all the different wonderful parameters of the voice, and it helps us be able to analyze and determine what is going on with the vocal folds, if we need to be concerned with some type of vocal paralysis. There could be that, or there could be, Parkinson's disease, where they might be having issues with their intensity, being able to sustain a vowel, if I was monotone, like if you saw my pitch here, that it was just all the same level, then there would be some concerns there, because I might have something like dysphonia, where I just wouldn't be able to deviate my voice to be able to have a good conversation. And this happens to be a great way to help others realize where their areas of voice concerns are having, so that you could help them be able to improve on those. And I am hoping that I had all of the correct parts to this, and I learned a lot from this, so I appreciate this assignment. And I know there is still a lot more for me to learn. So